Hi everyone, I am Dr. K. Kritika, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology. Now I am going to take the topic correlation and rank correlation from the subject statistics. The first one is correlation. The meaning of correlation is the relationship between two variables. The correlation coefficient formula is R of x comma y is equal to covariance of x comma y divided by sigma x into sigma y. Covariance xy is equal to summation xy by n minus x bar y bar. Here n is the number of data, x bar is called the mean of x and y bar is called the mean of y. Sigma x means standard deviation of y. It is defined by root of summation x square by n minus x bar square. Similarly, sigma y is defined by root of sigma y square by n minus y bar square. The another name of correlation coefficient is Karl Pearson's coefficient of correlation. The correlation coefficient value is always lies between -1 and +1. When R is equal to +1, exactly +1 means there is a perfect positive correlation between two variables x and y. Instead of this +1, suppose we getting 0.6 or 0.4 something, it is called the positive correlation. We don't use the word perfect. When R is equal to -1, there is a perfect negative correlation between the two variables x and y. So instead of this -1, suppose we having 0.1 minus 0.4 minus 0.2, it means there is a negative correlation between two variables. When R is equal to 0, the two variables are uncorrelated, or we say that there is no relationship between two variables x and y. If covariance of x comma y is equal to 0, means then x and y are called the independent variables. So this problem is based on correlation. Calculate the correlation coefficient for the following data. So here x is called the height of father in inches, y is the height of son in inches. So solution. So in the first column we write the x data as it is here, and in the second column we write the y data. In the third column just we multiplying x and y. In the fourth column just we squaring this x, we getting x square. And similarly in the last column we squaring this y. That means it is you getting y square. So after we finding x square and y square, we calculate all summations. It means summation x, summation y, summation xy, summation x square and summation y square. Now we write the correlation formula. R of x comma y is equal to covariance by sigma x into sigma y. So before we finding this sigma x, sigma y, that means standard deviation of x, standard deviation of y and covariance, we calculate x bar and y bar. This x bar formula is summation x by n. We write the summation x from the table. 544 by 8. Its answer is 68. Similarly, you find y bar. Its answer is 69. Next, we multiplying x bar and y bar. Answer is 4692. So after calculating x bar and y bar, we finding sigma x, sigma y and covariance. So here we substitute, we write the summation x square value from the table 37,028 divided by 8 minus already we having x bar. Now here just we squaring this x bar. So answer is 4624. So then finally we taking square root, answer is 2.121. Similarly, we finding sigma y. Its answer is 2.345. Then calculate covariance of x comma y. Its value is 3. So after finding sigma x, sigma y and covariance, we substitute all these three in correlation formula. So answer is 0.6030. So definitely this value lies between -1 and +1. So our answer is correct. This is the second problem. The question is same correlation coefficient. So here one x data is given and y data is given. So here using the same correlation formula, we calculate our correlation. So its value is 0.898. So this value is also lies between -1 and +1. The next topic is rank correlation. Here there are two types. One is non-repeated, another one is repeated. So rank correlation notation is rho of x comma y. The rank correlation coefficient for non-repeated rank is this: 1 minus 6 times summation di square by n into n square minus 1. Here n is called the number of data. Di means it is the difference between rank of x and rank of y. Here the first problem is the rank correlation coefficient for the following data. But here the two data is nothing but the rank in x and rank in y. So solution. So in the first column we write the rank in x. In the second column we write the rank of y. In the third column we find the difference between two ranks. So di is equal to xi minus yi. In the fourth column we squaring this di means di square. So after we calculating all these, calculate summation di and summation di square. The rank correlation coefficient formula is this. Then finally we substitute the summation di square. We write it from the table. Then n, here number of data is 7. So n square minus 1, 49 minus 1. So final answer is 0.6429. So rank correlation coefficient also lies between minus 1 and plus 1. This is the second problem. Topic is same, rank correlation coefficient. Answer is 0.8. Do it yourself. The next type is repeated ranks. The rank correlation coefficient for repeated rank is rho of x comma y is equal to 1 minus 6 times summation di square plus m into m square minus 1 by 12 whole thing divided by n into n square minus 1. N means number of data. M is called the number of times an item is repeated. But this full term m into m square minus 1 by 12 is called the correction factor. The first problem is a sample of 12 fathers and their eldest sons have the following data about their heights in inches. Find the rank correlation coefficient. So here the question is rank correlation coefficient, but the data are, the first data is fathers. That means the height of fathers in inches are given. Similarly, the height of sons in inches are given here, but ranks are not given. So before we start the problem, we calculate the rank of x and rank of y. So here the number of data n is equal to 12. So in the first column, we are going to write the x data, and the second column, we are going to write the y data. So in the third and fourth columns are very important because here we are going to find the rank of x and rank of y. To find the rank of x, we consider this x column and find which one is the highest value. Here 71 is the highest value. So here we put in first rank. Then 70 is the next highest value. So we put in second rank. Then 69 is the third highest value. So here we put in third rank. The next highest value is 68. It is 2 times repeated and is in the position of, it occurs in the position of 4th and 5th position. So the corresponding ranks are 4 plus 5 by 2. Its answer is 4.5, 4.5. The next highest value is 67. It is also repeated 2 times. So the rank is 6 plus 7 by 2. So its value is 6.5, 6.5. Similarly, we find the rank for the remaining value. So now we move to the y column. So here the highest value is 71. So here we put in first rank, and 70 is the next highest value. So here in this rank of y column we put in to second rank. Then the third highest value is 69. So here we put in third one. The next highest value is 68, but it is repeated 4 times. It is in the position of 4th, 5th, 6th and 7th rank. So the corresponding rank is 4 plus 5 plus 6 plus 7 by 4. Its value is 5.5. So here you put in 5.5, 5.5, 5.5, 5.5. Similarly, find the remaining ranks in y column. So after we finding this rank of x and rank of y, the difference di is equal to between ranks is xi minus yi. Then finally we calculating the squaring of this di is di square. So these are the procedures to find rank. So this is the rank correlation coefficient for repeated rank. So now we are going to find the correction factor. So correction factor formula is m into m square minus 1 by 12. So in the x data, 68 is repeated twice. It means m value is 2, not 68, it is just 2. So here we substituting m is replacing m by 2. So your answer is 0.5. In the same x data, the another value 67 is also repeated twice. So again m is 2, we substituting m is 2 and find the value of correction factor, it is 0.5. So now we move to the y data. So in the y series, 68 is repeated 4 times. So m is equal to 4. Substituting m is 4 and finding this value, correction factor value, its value is 5. Then in the same y series, 66 is repeated twice. So m value is 2. Substituting here and finding the correction factor's value is 0.5. In same y series, the third value 65 is repeated twice. So again, we substituting m is equal to 2. Then correction factor value is 0.5. So now we substitute all these correction factors and summation di square in this formula. Then 1 minus 0.277. Then final answer is 0.722. This value also lies between minus 1 and plus 1. So our answer is correct. So this problem comes under rank correlation coefficient. The same here, x data and y data are given, but it is not rank. So before we start the problem, using this x, we calculate rank of x. Using this y, we calculate rank of y. Then apply the same procedure. Then finding row of x comma y. Its value is 0.5454. This value also lies between minus 1 and plus 1. Do it yourself. Hope everyone understood. Thank you.